Hi folks, welcome to April 6th, the week of April 6th, examples, problems for chapter 10. These are referred to in the notes that I've provided in the DL4 folder. So example 1, we have a 3 kilogram particle that has the velocity given by this vector equation, 3I minus 4j meters per second. And we're asked to find the x and y components of the momentum and the magnitude and direction of the momentum. All right, so work on part A first. The x and y components of the momentum. So momentum is just mass times velocity. So in the x direction, we'll call that Px is going to be the mass times the velocity in the x direction. The mass is 3 kilograms. Velocity is 3 meters per second, so you have 9 kilogram meters per second. So that's the x direction. In the y direction, we're going to use the same procedure. Momentum in the y direction is the mass times the velocity in the y direction. That's 3 kilograms still. Now the velocity in the y direction is a minus 4 meters per second. So our momentum in the y direction is going to be minus 12 kilograms meters per second. Okay, part B. Find the magnitude and direction of the momentum. Okay, this is just, the first part of this anyway, is just a vector. In fact, all of it is just a vector problem, going back to the beginning of the semester. Magnitude of the momentum. So the magnitude of the momentum is going to be the square root of the squares. So that's the square root of 9 squared plus minus 12 squared. Minus sign goes away because it's squared. So this ends up being 15 kilogram meter per second. Now, direction. So we're going to do the same thing we did with other vectors, with velocity or with acceleration. We'll draw out the x. This is 9. The y is 12 minus 12. By vector addition, right? That's the resultant. We know that that's 15. So I'm going to call this the theta, the angle that I'm going to use to describe it. So theta, I'm going to use tangent, but since you have all three, you could use any function that you want. Minus 12 opposite over 9. So theta is comes out to be a minus 53.1 degrees. Okay, so this describes it because minus is measured clockwise, whereas positive angles are counterclockwise. Yeah. Okay, so next one, example 2. We have a 40 kilogram child standing on a frozen pond. The child throws a 0.5 kilogram stone to the east at a speed of 5 meters per second. We neglect friction. Find the recoil velocity of the child. So on this frictionless surface, if they throw the stone in one direction, they should move in the other direction. Okay, there are no non-conservative forces. All we have to worry about here is conservation of momentum. So conservation of momentum. So the momentum before is the momentum of the stone plus the momentum of the child. And then after, we have the momentum, we'll give that a prime to signify after, of the stone, and a prime for the momentum of the child. All right, so initially, I'm just going to use, I'm going to shorten the subscripts here, MSVS plus MCVC equals M1 V1 prime, or MSVS prime plus MCVC prime. Okay, just substituting mass times velocity for momentum. Initially, the velocities are 0. Child's at rest, stone's at rest. So that means that these two quantities, the sum of those have to equal 0. So 0 must equal the mass of the stone, which is 0.5, times the speed at which it was thrown, which is 5 meters per second, plus the 40 kilogram child times the velocity of the child. And when you do that out, the velocity of the child after the child throws a stone is minus 0.0625 meters per second. Okay. Next one.